Morning, everyone. Hi, this is TK here. Thank you for joining our webinar. We're going to start in a couple of minutes, so hang in there and we'll get started soon.
For joining us. We're super excited to have you. You're joining the Roadway and Bridge Design Workflow webinar as part of our AEC Collection Essentials series. I'm Annie Fan. I do product marketing here at Autodesk representing civil infrastructure. Now, before we begin, I will dive into some housekeeping notes. First, you are joining with your computer's audio system. So if you experience any audio issues, it's usually your web browser. So try refreshing your web browser or switching to a new web browser. Second, we highly encourage you to ask your questions throughout the entire webinar. And you can do that by locating the questions panel on your webinar menu and type away. So please don't be shy. We will also have a questions and answers live session at the end of the presentation. And then the third point I want to make is this webinar will be recorded. So you will be able to rewatch the webinar at your leisure, and you can also share the recording with your colleagues. Now, before we get to the fun stuff, I want to make a point that we might make some future or forward-looking statements during this presentation. Please don't take any of these statements as a promise or a guarantee of project or product delivery from Autodesk, and please don't make any purchasing or investment decisions based off of those future statements. You are in amazing hands with our experts, Era and Andrew here, who will present to you today. Between the two of them, they have decades, about 60 years of experience combined, both as civil engineers and as well as working in Autodesk, where they're helping us shape the vision to make sure that our products deliver and work for civil engineering teams. So we're super excited to have them here today. Andrew will focus more on the roadway part of a transportation project, and Era will introduce the bridge design workflow that we've recently rolled out. All right, so as we were thinking about this webinar series, we wanted to focus on multi-tool products with the lens of outcome-based design. So whether you're an engineer, designer, or contractor, we want to help you move from early design through to construction. We do have a new webinar coming up for APAC. It's going to be on generative design, which is a super popular topic. It's going to be held in November, so please look out for the invite. We really hope to see you again soon. As we're thinking about how we deliver better experiences in our products and in our software, here at Autodesk, we're focused on assisting and helping you achieve your desired outcomes. So whether you're focused on improving project delivery and improving design for your clients and increasing your business growth that way, if you're focused on sustainability or reducing risk or driving up operational efficiency, we have these outcomes in mind as we continue to make the products that hopefully you're using every day even better. Okay, so with that, I'm going to let you know that we're going to add a couple of links, or several links actually, to the webinar chat panel. The first one we're going to share with you the AEC Collection website, where you can download all of the software that's included in the AEC Collection for 30 days. There are a lot of tools in that collection, so we hope that you explore that. Secondly, we're going to share the webinar link to our portal, where you can look at on-demand content that we've created, as well as sign up for upcoming webinars. Now I want to get to know who's joining us in this session. And so we're going to launch some polling questions. The first one that we're going to ask is, what's your role on a transportation project? If you have multiple roles, feel free to select more than one. If we somehow didn't capture your specific role, we still want to get to know you, so please feel free to answer in the questions box and let us know. So I'll give everyone a moment. All right, we see some answers trickle in. And we can go ahead and close that poll. And we're going to share the results. So it looks like most of you are in road design, very exciting for Andrew and for all of us, followed by BIM management or project management, and surprisingly a lot of people in contracting. So we're excited to see this diversity, and we hope this webinar will show value for all of you. All right, the next question is specific to bridge design. If you are using BIM tools, we want to know what software you're using. So the options include Autodesk products, of course, as well as our competitors such as Bentley and so forth. So we'll give you a moment to answer. Okay, I suspect this might not be relevant to a lot of people, but I do see several votes coming in, which is great. Give you another quick moment. And we're going to close the poll and share the results. Awesome. Yes, we have Autodesk fans, hopefully, here. And we're hoping that, especially if you already have the AEC collection, you are further using the collection to its full benefit and value. So super excited to see that most of you are using Autodesk products, although we do recognize that there are other solutions out there. And so we hope that you can get better clarity on where we position ourselves compared to other options for you. So thank you so much. The next and last question that I have is, we want to know what's most painful or challenging for you on a typical transportation project. And if you have more than one pain point or a headache, feel free to select as many as apply. If your problem is something else, again, feel free to let us know by typing into the questions panel. Okay, this one probably takes more thought, but we're closing that poll and sharing the results. All right, so most of you said the ability to analyze different designs early on, and I think with Era's portion, especially for bridge design, the new workflow is going to change all of that for the better. So we're super excited to share that with you. And then next after that is collaborating and coordinating with different roles on a project. Apologies that that sentence wasn't completed, but thank you so much. I think these 2 points will be especially hit on in our presentation. So with that, I don't want to delay any further, and I will go ahead and hand off the presentation to Andrew. Andrew, I'll make you the presenter, and then you'll have the floor.
Thanks, Annie.
Awesome. Great, we see your screen.
Thank you. Ara, did you want to do the brief introduction?
Yes, I will. Just going to go on to the next slide. So we put together a presentation of kind of the latest aspects of the workflow, which really focus on the collaboration between the road design team and the bridge design team, and the team doing all the technical documentation, drawings, and details for the bridge, and how you can collaborate, make changes, at any stage, whether you're road design, bridge design, or technician on documentation. But we also wanted to create the presentation around a reasonably complex bridge. This is a bridge that was built a few years ago, and we decided, well, what if you had access to today's latest technology and tools from Autodesk to tackle such a bridge and road project? So that's kind of the idea behind this presentation. And if you go to the next slide, you can see here this bridge is curved in plan, has variable depth girders, has a corridor model that Andrew's going to go through that has all the roadway details, and has very specific architectural pier layouts with slightly unconventional bearing details. So this is going to be the focus of the bridge part of it. Andrew's going to focus on how would the road design team bring complex roadway design into play for the bridge design team. So yeah, back to you, Andrew.
Yeah, thanks, Ara. Yeah, good morning, good afternoon. Yeah, my name's Andrew Milford. I'm the product manager for civil infrastructure, focusing on roads and highways and land development. So today, as Ara mentioned, myself and Ara, we're going to work through a bridge design workflow using a combination of Civil 3D, Infraworks, and Revit. I'm going to be covering off the Civil 3D interoperability side of the workflow, and then I'm going to hand over to Ara, who will guide us through the Infraworks actual bridge modeling and the Revit interop. So we'll start at the beginning. We're going to start with a new Civil 3D project. So in this case, we do have a project already existing, but I just want to do a little bit of housekeeping up front. What's some of the most important aspects we need to look at when we're setting up a Civil 3D project is we need to be very conscious of coordinate systems. In this case, you can see in Civil 3D, we're adding a coordinate system for a model for where we want to be in the world. So it's not necessarily mandatory in Civil 3D, but if we're interacting with Infraworks, this is actually quite essential. So in this case, in Civil 3D, you can see we're actually accessing and using the a Great Britain coordinate system. And in the corresponding tab in Infraworks, you can see we can access it via the Manage tab through Infraworks through the model properties, and we're setting the same coordinate system between the two. So this is just getting our project off on the right foot. So if we run to the next slide, you can see I've got a video here. Okay, so in this particular case, we already have an existing Civil 3D corridor, but what we're doing is there's no coordinate system set up. So we're going to come across to the Settings tab on our prospector. We're going to right-click on the drawing name and access the Civil 3D drawing settings. Now, in this particular case, we're just going to simply sit in the units and zone. Notice we have the categories, which currently has no datum. We're going to change this to our region of the world. In this case, we're going to head to Great Britain, and we're going to set an available coordinate system. So in this case, we're going to select a projected coordinate system. We're just going to review the description and accept those defaults. And that's now setting the project coordinate system ready for importing to Infraworks. Now, from the Infraworks side here, you can see here, we already have an Infraworks model set up. We have some surface, we have some raster imagery brought in. We've got some high resolution survey information. But what we're going to do is just make sure that under the model properties, under the Manage tab, in the model properties there, we're going to specify the user coordinate system to match the exact same setting. Now, in this case, you can see the two buttons on the right there. The pull down arrow will bring up the last 4 coordinate systems you've used. If you click on the world button, you're brought with the exact same coordinate system model that is available in Civil 3D. So we're essentially just setting it up like for like. To accept that, you simply double click to confirm, and then you hit OK or apply. And the project is now set up, ready to begin the design and translation process. So moving on, this is a proposed cross section for the bridge that we're going to be modeling today. This was actually provided in just a basic PDF format, which is kind of typical, during the design when you receive a design specification or brief. So this cross section, again, came from PDF. This is just a one-way super elevator bridge. You can see it has varying crossfall between 5 and 7%. So it's going to be quite complex to model and build out in the field. It has a roughly 7.3 meters of travelway or carriageway and about 4.3 meters of shoulder. You can see additionally, we have some more complexity based around footpaths each side with a parapet. 250 mil thick concrete deck with 125 mil surface layers, and we have provision for 6 steel plate girders. So in this model, we need to be highlighting the extent of what are we going to actually be modeling in Civil 3D, and how is it going to correspond to the bridge modeling dimensions inside of Infraworks. This also corresponds to the outer extent of the bridge deck required in the Inventor model. So what actually needs to be modeled? So in this particular instance, you can see we're actually modeling from the left outer edge across to the right outer edge, because the assembly we're creating in Inventor is going to be built from the outside in. Now, that's not to say we can't build it just from the inside out, but this is just giving us a good starting point. And the key is here, we don't need to be overly detailed on the Civil 3D assembly as we go across the bridge. This is the Civil 3D assembly used to model the bridge in its current state. Notice there's actually quite a high degree of detail in here. So for exporting to Infraworks, we don't need this much detail. This model contains not only the wearing surface and the deck concrete itself, it also contains, you can see there, the steel girders and all of the parapet details. Now, while this looks really good in a Civil 3D model, it's actually not required for the Infraworks bridge. It's just way too much. Infraworks is actually going to handle all of the substructure and superstructure details for us. So this is a high level of detail. In this version, you can see here, we're going to strip away the girders and the parapet of the superstructure, and it's going to leave a more basic set of shapes from which to model the bridge. Note the overlap on the deck down here in the bottom left corner. This may look a bit odd, but this is actually just part of the Civil 3D. This is fixed in the Civil 3D model by assigning targets to the Civil 3D corridor, and this will create a seamless concrete deck shape. But if we want to go even one step further, and we're not doing it in this example, but we're actually providing a low level of detail, we only really need to model the basic shape of the bridge with just the top surface. So note this, in this version, we are actually extending our pavement surface to cover the outer extent of the parapet, because our Inventor model actually, again, I've mentioned before, works from the outside inwards when placing the Inventor geometry. So this session doesn't go into depth on how to model all the Inventor parts. However, it's just good to know that the overall width of the Inventor deck model that we're creating is going to correspond to the overall width of the Civil 3D assembly that we created from the previous slides. For example, in this particular case, from our PDF, the width for the entire cross section from left edge to right edge is approximately 16.7 meters. So therefore, the Inventor model width we've shown here measures exactly that, 16.7 meters across, exactly identical to the Civil 3D assembly. So with that in mind, this is the Civil 3D corridor we already have in place. Now we're going to do a little bit of substitution in the model to sort of replace the more complex assembly type with a more simple type. This is the plan of the corridor we're going to be working with, and we're going to dive into what we need to better understand and prepare the corridor model for export to Infraworks. And we're going to take advantage of the new Infraworks 2021 capability of importing the whole Civil 3D corridor and mapping those components. And we're going to focus purely on the region of the corridor that's crossing over the bridge. So let's just dive in and take a closer look at that. So you can see in this case, we have the corridor, which shows the highly detailed assembly in our cross section. You can see the girders and the parapets over on the right view here. You can see as I drag my section view across, you can also observe the super elevation being applied to the bridge. And you can see around this point here, it does vary from between 7 and 5%. And you can see we've also split the screen in Civil 3D just to maximize what we can actually see. So the assemblies here, you can see they're actually quite detailed. We have 2 of them over this bridge. We're going to keep the 2, but we're just going to simply take a copy of these. So let's fix the complexity issue. We're just going to grab these in Civil 3D. We're just going to copy them up in the model. And all we're going to do in this case is select each one. We're just going to rename it both in our annotations, we're just going to call these no girders or something similar. And so once we've done some basic renaming, we're just going to go in, select all those beams, which are custom sub-assemblies in Civil 3D, select the parapets, and delete those elements. So you can see how easy it is just to edit your assemblies in Civil 3D. Now, one thing we also should be doing here, it's just good housekeeping, is make sure that we actually rename the assembly as well as the matching text that goes alongside of it. We're going to repeat the process on the second assembly. Just delete those components. And again, can't emphasize, good naming convention makes it much easier to jump in. Okay, you can see in our corridor properties box here, you can see our two regions of crossing the bridge here. All we're going to do is come across to the assembly column. From the assembly tab, we're just going to swap those out. So we're going to swap out assembly 01 and assembly 02 with the no girder equivalents. And then we're simply just going to rebuild the corridor. And again, just in the interest of good housekeeping, I'm just going to rename it. You can rename the assemblies either through the assembly properties dialog or through the typical AutoCAD properties palette. And again, just keeping it simple will make our life a lot easier when we move across into Infraworks. And so once you've rebuilt the corridor using the new assemblies, you simply save your work, and then we can move across into Infraworks and begin the process. And there we are, we've just taken out the high detail. Okay, so we're moving across into Infraworks at this point. So we're going to add the Civil 3D drawing. We're going to use the Infraworks data sources to do this. And we're just going to look at the process on how we bring that data across. Once we import the required geometry, we need to go through some basic configuration, which the next video is actually going to demonstrate. And again, once we've imported the Civil 3D corridor, we are presented with quite a few options to configure our data. It may look a little daunting at first, but it's actually quite simple once you do it once or twice. Some of the options include road options. Now, this was introduced in Infraworks 2021. When we have a corridor with a corresponding alignment, we are presented with the choice to choose between selecting what's called a Civil 3D corridor component road or an Infraworks native component road. And you can see on this slide here, say in row 2, we have an alignment that doesn't have a corridor. It's going to default to a component road. It's also worth noting, you'll see out-of-date corridors that are trying to be imported. They're going to be displayed with a warning symbol. They will still import. This is just receiving a warning. The component mapping is a section that we're going to cover in the next slide in just a little more detail. This is going to help us texture and create a much more visually appealing model. And then we have some road grading options where we can choose whether to use the Civil 3D gradings, our daylighting. We can choose either no grading or the Infraworks defaults. And from the component mapping section, this feature is new to Infraworks 2021, and this involves essentially configuring a table to apply textures to your Civil 3D corridors, and it's based on 3 fields. You can see we have, in the Civil 3D side, we have sub-assemblies, we have shape codes, and link codes. And again, it does look a little daunting, but it is actually really easy to set up. The text fields are not case sensitive, and you combine fields to provide more granular control over what gets textured in your model. And again, this goes back to good housekeeping with your shape naming, link and point code naming conventions. Additionally, there is actually a wildcard feature that means you don't have to actually type in a full field name. For example, if I had an assembly called project_pavement1, I just have to type in the word project_pave, and Infraworks will automatically apply the corresponding texture to all sub-assemblies starting with that prefix. And you don't need to actually apply a wildcard symbol, is worth noting as well. You just need to type in the name, and Infraworks will pick it up as a wildcard. And essentially, the component mapping will turn something that looks like this. So this is the road that's been imported natively from Civil 3D with the default settings, so straight out of the box. And when we apply component mapping, we get something that looks a bit more like this. And this only takes really just a few minutes to adjust the textures through the component mapping tools. Okay, so let's have a look at this in action. Let's start by adding our model through the data sources. So we're going to come up to our data sources panel. We're going to choose our import and import our civil 3D drawing. We're going to navigate and select the file. It's going to take a few seconds to actually go and interrogate the data. You can see in this particular choose data sources panel, we get the choice of choosing either our roads, which are our alignments and corridors. We can bring in all of our surfaces that exist in the civil 3D drawing. And we can also import the corridor coverages, which are our corridor links. Now, in this particular case, we're only interested in the roads. So I'm going to exclude everything and just reselect the roads. And you can see over on the panel, we have our new roads category. And we're going to configure this data here. We're going to either right click on it and select configure. We can highlight the file and come up to the top panel and say configure data sources, or we're just going to double click on the file to enter the configuration dialog. So in this particular case, we're going to look at moving across to the Civil 3D tab, and you can see these are all the alignments and corridors. Now you can see in this case, we have instances where we have our alignments, and we have some where we have no corridors. We're simply going to select those, and we're just going to turn them off just by clicking the checkbox on the left under the enable. And you can see by default, it's going to try and create a component road. Now that's an Infraworks component road. The rest are going to create corridor component roads, which is the new Infraworks 2021 option. We're going to keep them as corridor component roads because it maintains a link back to the Civil 3D file. The component mapping, we're going to return to that later. And the gradings, we're just going to keep the default Civil 3D gradings or our daylighting because we want to maintain the design intent. We're going to click close and refresh. And it's going to take a few seconds to process. And you'll note that the coloring from the previous slide, the red indicates areas where the mapping has not been successfully applied. So we can actually select a region on screen, and then we can view its properties in the stack. So if I select this particular bit of pavement, you can see we can look at the shape code name, the link code, and the subassembly name. Now, if you've got good naming conventions, this should be really easy to set up inside the component mapping. We can actually access the component mapping from the stack. So with the component selected, we select component mapping, and it's going to bring up the same dialog as what we saw in the initial configuration. So what we're going to do is just add a new row. I'm going to select the column. We're going to add a new row based upon the subassembly name. In this case, it's called JENG Major Highway. Click New, and it'll insert the new row below. And because the subassembly name, I'm just going to simply type in the name JENG Major. Now, I'm not even going to type in the full name. I'm just going to type in the word high, and this will pick up everything with that as a prefix. I don't need to populate the shape or link codes. And then all I need to do is change the texture under the Infraworks column. Just going to select a nice asphalt or a dark surface. And we hit Run Rules. And that'll go and apply the rules across the entire model again. And you can see that pavement that we selected and all of the other regions have now been retextured. So we'll apply this again. We're going to apply this to the earthworks subassembly. So I'm just going to pick a section out to the left. This one's has a subassembly name of earthworks, but it also has a shape code name called topsoil. So let's apply it to a different column. So we're just going to add a new row in there. We'll get rid of the subassembly value in the column. And we'll use, in this case, we'll use a shape code name. So I'm going to go into the second column. I'm just going to add the word topsoil. We're going to change it to a nice grass texture. Click OK, Run Rules. And you can see it's applied it to all the topsoil textures throughout the model. The advantage of this approach is if we go back into the component mapping options through our configuration dialog, back to the Civil 3D tab, we do have the ability to actually import and export some settings. So once you've set this up once, you simply export it out. In this case, I'm going to bring in a saved mapping file. Click open, it'll override the columns, and we just simply reapply. And we can apply the whole component mapping process to everything else. Okay. So we've imported our Civil 3D corridor. Let's place a preliminary bridge. So I'm not a bridge designer by any means, but I certainly understand enough about how dimensions, spans, and clearances work to take an educated first pass at the model. So an engineer can come back later into the same model and change it based upon their own requirements. So in this case, we're going to create an Infraworks bridge. And we're simply just going to create a conceptual bridge. We're going to select the roadway itself. And again, very basic Infraworks. This has been in the product for many years. We're going to select our component road. I'm going to right click on it and select Add Structure, Bridge. Click on the start of where the bridge is going to, the first abutment. And then we're going to click again to place the end abutment. And this can take about a minute or so, but you can see we have a pretty good first pass at the bridge. In this case, we're going to select the bridge. Okay, we're going to select the bridge and we're just going to start to change its components. So we can turn off the bridge deck so we can get a better look at the girders underneath. And we're going to simply change out the girder style. Again, we're going to use an Australian Super T as opposed to an AASHTO I-beam. So we're going to come across to the stack, change it to a T5 Open Super T. We're going to make the one change. And we're just going to propagate those changes through to the rest of the model by selecting right click, apply it to all girders in the project. Second, you can see the pier in this case. You can see we have some pretty odd looking bearings in this particular instance. We're going to select the pier, and over on the stack, we're just going to change some of these slope parameters. Now, these are parameters that come from Inventor. We're going to put a -7 on the left and a +7 on the right. And you can see we can adjust the slope of the pier as well. Notice the girders are updating automatically due to the fact they're parametric bearings. We'll turn the deck back on because we need to actually change out the deck component as well. So we select the deck and we're going to change the deck profile from the default component deck. Just being mindful now, we do have a new option to offset the new deck from the top of the imported road component. And we're going to change it out to an S2. And so this whole process from importing the roads to actually creating a preliminary bridge can take anywhere from anywhere between 5 and 7 minutes. So it is a really quick process to get that underway. Okay, so what happens when the model needs to change? So let's have a look at how we can handle change in the model. So in this case, the road engineer has lifted the roadway by 1 meter or so. Okay, these processes and changes can be very time consuming for a bridge modeler to implement, and Infraworks makes it really easy. So let's have a look at, I'm going to lift the roadway bridge here in Civil 3D. This is my profile view. I'm going to select my profile. I'm going to make a pretty severe change to the road model. So I can pick up the grips and just move it. I'm going to drag it, maybe increase it by about 1 meter across the entire bridge. So I'll raise the tangent up on the right side, and then I'm going to reduce the curve radius, reduce the K value a bit, just to make something a little bit more noticeable. Now in this case, I've made the change. I just need to come back into my corridor, and I need to rebuild the corridor in this instance. That's it, that's all we need to do. So from now, we just need to save the model. And we're going to head back into Infraworks once that drawing has been saved. Okay. Now, it's not an automatic process. We need to come back to our data sources, find the original source file. We're going to right-click and select re-import. And that's all that's required. The whole bridge model is parametric. Infraworks will update the bridge model and it'll actually recalculate everything. So all the piers, all the girder locations have all been updated to reflect the new surface profile of the imported corridor. So Infraworks also allows us to publish the bridge to Civil 3D or Revit, and we're going to bring this into Civil 3D for documentation purposes. So in this particular case, you simply select the bridge, right-click on the bridge itself, and you have the option to either create a new export, or you can actually update an existing bridge. Once you've selected this case, in this case, we've selected create a new bridge. We're going to simply select the location where we're going to output the IMX file. We have an option to back up the proposal name. And finally, it's just going to go ahead and produce the IMX file, which is usually takes a minute or so to process. And lastly, we're going to import the Civil 3D, the Infraworks Bridge back into Civil 3D. So you can see back in Civil, we're going to navigate to our Infraworks tab. We're going to open up the model in the import options. And we're just going to navigate to the folder where the IMX was originally output from. So in this case, it's under a folder called Autodesk Civil Data, which is in this case on my local drive. It's going to go into a subfolder called the project name, the Infraworks project name. Then it goes into a folder called the actual proposal name. Now, because it's an IMX file, we need to synchronize the coordinate systems. So I'm going to simply say set the coordinate system and match the coordinate system to the Infraworks. The bridge export, we don't need to specify a selection area because it's only taking the portion of the IMX only export of that part of the bridge. And we can set up some exchange settings here. I'm going to set up some layers for the bridges. I'm going to go down to the bridges option, and all I'm going to do in this case is specify some out-of-the-box layers for my deck, my abutments, and all the other components. We'll save that off for later use. Call that bridge presentation. We are going to refine the selection set. So we don't really want all the surfaces. We're going to unselect everything, scroll down, and just select the bridge to import. We're going to hit OK and open model. And then we can select the bridge either by a single component. Each set of objects, in this case the girder group, is all grouped together, or we can come across to the prospector and select the entire bridge from the prospector, and we can have a look. It's actually brought the entire model across as 3D solids into Civil 3D. And lastly, just to finish up, you can see in this particular case, I've added the bridge to a profile view for our long section outputs. In this case, it's really just using native Civil 3D functionality. We're just saying from the Home tab on the ribbon, we're projecting objects to the profile view. We select the part of the bridge that we want to add. Then we simply select the profile view we wish to add it to. And we can actually project and apply annotations to all the bridge objects, including things like the deck, the girders, abutments, piers, foundations, as well as our generic objects, which include bearings. Once we've simply added it and projected those objects, we hit OK, and it adds them to the model for us. So that brings me to the end of the Civil 3D component. I'm now going to hand over to Ara, who will demonstrate the bridge modeling capabilities in a bit more detail inside of Infraworks. So over to you, Ara.
Thanks, Andrew. I'm going to share my screen now. Am I presenter? Okay. Can you see my screen?
We can.
Yeah.
Great. All right. So Andrew kind of looked at the roadway persona. Now let's dive deeper And I'm going to jump ahead to instead of using the corridor, which is the starting point from the roadway model, you have the option of switching over to a component road in Infraworks, just to illustrate that your starting point could be this as well. So the component road can include all the details of the lanes and barriers, etc. as well. So you have both options. So now let's kind of jump ahead. Now the bridge persona, the bridge team is going to place a bridge. Now Andrew showed the early design of a bridge. What we're going to do is use the Infraworks in context modeling to replicate that much more complex bridge with the variable depth girders and all the framing details. By in context, we kind of look at the layout, we look at aerial imagery, maybe we have point clouds, anything that helps us make decisions, and we're going to move the piers around and rotate them to really fit the constraints of the project. So the first part of the bridge modeling is, let's get the right spans and the right orientations and the right number of girders. And then we'll come back and leverage the real strength of the Infraworks Bridge workflow is it's completely open-ended in terms of parametric components. We leverage the solid modeling capabilities of Inventor, which allows us to model every bridge component to a very high level of detail in a very robust way as well. So here we kind of placed the piers at the right locations, and we can also leverage integrated spreadsheets for all the engineers on the call. Just click on the bridge and have access to all the data of the bridge. Every parameter is listed. You can make changes en masse in the spreadsheet and simply update the bridge. I did this just to have even proper span dimensions that match the existing bridge exactly. And then we start interacting with the bridge. I'm just going to skip ahead to changing the superstructure to steel girders, and then we'll kind of take it one step further. We'll make the girders variable depth. So in Infraworks, you can select the specific girder and select these slices that allow you to change dimensions of a girder. And remember, you can add your own girders. They can have any number of parameters that you choose to have. But at any slice location, you can change the dimensions. In this case, we're just changing the depth of the girders to make it a tapered variable depth girder, and to better reflect the exact bridge that we're looking at. And if we take it further and we continue, we can quickly apply it to all the girders in the same span, and we can do the same type of operation on the adjacent spans to have a proper continuity. So really, this is 10 minutes into your project, you have a bridge which has the right type of superstructure, the right layout, and the right locations of the substructure. We're going to now jump into, let's make this bridge much more specific. And again, we leverage content that you can create. So if the type of pier, this architectural type of pier, is not in the library, you can always create it. So I created some piers and a dedicated deck, and I'm leveraging these to make a more refined model. So here, I'm going to isolate the bridge by turning off the surface, and so we can look at the foundations in more clarity. And I'm going to go and switch the foundation. Every component of the bridge has an asset card, and from there you can select and open up the content picker, which shows what's available for that type of component in the library. Again, when you add your own components, they just append to the libraries and they work in the same way. Here, Inventor components can be simple or very flexible. This foundation allows a user to change its pile cap shapes and dimensions, and even really control all the piles independently, change the type of piles from steel encased concrete or Frankie piles or whatever you choose to do. So with parametric modeling, you're leveraging, you're providing the design team with components that they can manipulate and change to really meet their requirements. And we'll do the same thing. We'll go in and adjust the piers, switch them to this architectural pier, change some of the exposed parameters, maybe the diameter, maybe the spacing of the columns. And now we have a much more specific bridge with the right type of foundation, the right type of piers. We can then go in and start adding increased level of detail. So we'll start off with the bearings. We saw in the framing diagram that this is slightly unconventional. The bearings are underneath the steel diaphragms between the girders. So let's select the type of bearing we want, and we can create our own custom ones if we choose, and just apply them. And I moved it laterally. I'm going to apply it to the adjacent ones. And very quickly, we have a very high level of detail with the correct definition. What we added in the latest release, 21.1 of the AEC collection in Infraworks, is increased level of detail for steel bridges. And this is for all the framing, the cross frames. These are complex inventor objects that handle all the eccentricities of a real framing object that you can actually build. So you have gusset plates and offsets. As a designer, you simply have to place it, decide what the spacing is and whether they're going to be perpendicular or going to be staggered or skewed. All the layout, we don't have to worry about how do I precisely place it along the to interact with the girder dimensions. Infraworks knows how to handle the parameters of the girders with the framing. So if you were to change the spacing of the girders, if you change the depth of the girders, they would automatically adjust. Here you can see how we're increasing the level of detail of the steel bridge with the bearings and the diaphragms. And we'll add next cross frames. And the cross frames along the span, again, this is all new functionality. Select the girders. We spend a lot of time providing very refined in-context modeling so you can quickly lay out a configuration and then duplicate it for adjacent spans in an intelligent manner. Notice how each of these cross frames is automatically adjusting its depth based on the dimensions of the girder. So as you're iterating on your design concepts, you might be changing the dimensions and the layout of the superstructure. All these components would dynamically adjust. So here in a few minutes, we have all the framing of the main span, and then we can move on and tackle the slightly more complex layout where the piers are heavily skewed adjacent here. So let's have a quick look at that. I'm just going to pan over to the skewed part. Now, you need a lot of control to really model complex framing here. In this case, you might just decide that you don't want to skew the diaphragm over the pier. You might decide to keep it perpendicular. You need to have all this level of control to go into detailed design. And finally, we can go ahead and do the same thing for the diaphragms at the abutment locations. All these cross frames expose many, many parameters. In this case, I toggled on external stiffeners because we need proper bearing capacity. And really, we went from that nominal bridge, and maybe an hour later, you have a bridge which has all this level of detail, including the custom deck. You can see its geometry, and if you pan over the rest of the bridge, you'll see that this bridge is really ready to go for advanced analysis. This kind of bridge, curved and planned with heavily skewed supports, requires very advanced structural analysis. And creating these analysis models conventionally can take many, many days to create and calibrate. Well, we'll see next that it's fully integrated. We can leverage these refined models and extract advanced analysis models. Here you can see that I also varied all the flange dimensions along the girders to reflect the actual design. And now the bridge engineers and structural engineers can get involved and extract from these models a lot more information. So here we're going to select the bridge and say, let's create a grillage model. The grillage model looks at the whole geometry of the bridge, all the girders, all the spacings of the piers, and creates a fully calibrated analysis model that we can open up directly from Infraworks. And once we open it up in Autodesk Structural Bridge Design, which is also part of the AEC collection, we can look at all the details, maybe modify some of the material settings, and apply specific live loading conditions and run the analysis. But this is really at the disposal, within reach of the structural engineer, and derived directly from a very rich parametric model. As you change the bridge model in Infraworks, you can simply go ahead and create more advanced analysis models. A more advanced version might be a full finite element model, and this is what we're creating here. And it's not a black box. The full definition of the analysis model is available in the report. Every section calculation, etc., is available for review. And creating an FE model, a finite element model of a bridge like this, is very time consuming. But now it's done almost in real time, which means that our design teams, our clients, can now look at, in early stages of design, compare many options. Maybe you want to consider different span arrangements, or maybe constant depth girders, or maybe you want to consider composite steel box girders over plate girders, and quickly, by running these advanced simulations, determine whether they're more suitable, more economical, or easier to build. So this is a big step forward in terms of interactive analysis and simulation while you're laying out your design and evolving the design towards detailed design. And finally, if the bridge design team is ready, they can, as Andrew mentioned, just publish the bridge. So let's go ahead and I'm just going to skip over this part that shows the spreadsheets. We're going to publish the bridge, and you can publish to your local computer, your LAN, or to a BIM 360 project. All of those scenarios are available. Once a bridge is published, its data model is available for use in Civil 3D or in Revit. I'm going to skip over the Civil 3D part, which was covered by Andrew, and go directly into Revit. Now in Revit, you simply create a new Revit project, use a template of choice, and then import the published bridge. We introduced a lot more information for infrastructure in Revit 2021, so we added an infrastructure discipline and with bridge categories. So you no longer have to resort to picking the closest building category for the bridge components. You have dedicated bridge categories. These will be followed by other infra domains such as rail in the future. Now you can see how this very detailed bridge simply is available in Revit with no extra work. To create this model in Revit would be quite a task. Now you simply open this model up, and all the information, all the parameters came across. If we zoom in, you'll see that all the geometry and all the details are also there. And this is where all of a sudden we have three teams that are working side by side and collaborating. It might be that the road design team is still evolving the road design, and the bridge design team is looking at one of many concepts, and the documentation detailing is starting early, because really this is where you'll spend more time. So if you can start the Revit model early, that's a very good way to go forward, as long as you can accommodate changes. And here in Revit, you can see you might start adding rebar, you might create sheets with annotations. This is all standard Revit capabilities that you want to leverage. So now the three teams are working side by side, and if there are changes that happen anywhere along the way, we can accommodate them. So here you can see a sheet with the foundation plan and also the elevation plans of some of the piers. But a Revit model is far more than just geometry and drawings. There's a lot of information in this model. Whereas in Infraworks, we can get very high level breakdowns of quantities. In Revit, we can leverage schedules. We can get a list of every single component. Maybe we want to look at every bearing or every cross frame, make a table for bidding or quantities or estimation. So here I'm going to select the piers, for instance, which is one of the new categories that we added for bridges, and simply make a table of all the piers with all the parameters that we think we want to show in this table. So again, a lot of information is available at the fingertips of the design team. And this information can be further used in other downstream products like Assemble and all the design to field aspects of a Revit model. So here we have a table of piers, we can do the same thing and leverage maybe a full table of all the bearings and decide which parameters of the bearings we want to show in the table. Again, there's a lot of information, and you didn't have to model this very complex, geometrically complex bridge from scratch in Revit. You did it in context in Infraworks, which understands the road design and terrain and quickly allows the designer to modify and create these bridges. Now, finally, in the real bridge workflow, changes will happen, whether it's a road design change Andrew showed, or maybe the bridge design team decides to change the geometry of the bridge. Here's a simple case that we lowered the foundation. And we don't want the changes to automatically update Revit. It has to be organized, it has to be controlled. When the bridge design team is ready, they can publish a new version of the data model and put some comments so everybody else on the other teams understand who made the changes and why these changes were made. So here, when we're ready as a bridge design team, we're going to publish a new version of the bridge. Now, in Infraworks or in Civil 3D or Revit, you'll see that there's a notification that changes are pending. And if you accept these changes, notice the geometry and all the parameters are in the drawing here. When you apply the changes, the underlying Revit model geometry updates and all the derivatives, the drawings and the rebar automatically update. So this is a significant step forward over 2D CAD where you would have to go in and modify many, many drawings for even the smallest change. If you change the roadway the way Andrew showed, you'd have to change every drawing that is affected, every pier, every girder elevation, every foundation view that has the roadway, a deck, and the view. In this type of scenario, changes can be made in the roadway. They can be made at the bridge level at any time with no rework. So this is fundamental step well beyond 2D CAD. And I'm not going to spend too much time here, but really final thing to show is on the real project, we saw that bridge, but really there's many bridges in that interchange which are almost very similar. They have a different number of spans or girders. And we can leverage that from Infraworks. We can simply save the bridge that we just did to a library, and we're going to add a new road. I just drew a new road. I'm going to apply, add new bridges to this new road just to illustrate how a large road project or interchange with many, many bridges can be done very effectively by leveraging the work that we did on the first bridge. So here we're adding the bridges, and then we'll just simply make sure we have the right number of piers and girders, and then go ahead and apply the save bridge as a template that we see here. And in a few minutes, we have other bridges which have the same level of detail. Now, you would add the cross frames separately because that's really bridge specific, but everything else, the piers, bearings, foundations, all of that came across. So now the second bridge can be done, your starting point is much further ahead. You might just modify the in-context spacing of the piers, and in a few minutes have the second bridge or the third bridge with all this level of detail available for documentation or advanced analysis that we see here. So it's really a whole new paradigm of road design, bridge design, and technical documentation detailing of bridges and roadway projects in a very seamless manner. So that's kind of the extent of what we wanted to present today. Here you can see I'm publishing not just one bridge, but the whole interchange, and you can bring the whole interchange into Civil 3D that easily and manage changes from there.
Sorry to interrupt. That's awesome. I do want to get to questions and answers. I think several came in, so I want to make sure we have some time before the end. Yeah. We can still go over a few minutes too if we don't get to everything. Great. So
yes, that was the extent of the presentation from Andrew and myself, and we're open for questions.
Sounds good. Austin, if you can go off mute, you can go ahead and take it away.
Absolutely. Thank you, Andrew and Aaron. We have a couple questions. There aren't a whole lot, but we should be able to take care of these in a few minutes. So let's see. The first one, there were several comments that came in about e-certificates. And unfortunately, right now, we're not able to offer e-certificates, but we do have it on the list, and we hope to be able to offer them in the future. So hopefully in one of the upcoming webinars, you'll be able to receive those. Then going on to the presentation topics, let's see, there was a question for Andrew, I believe, that was about bringing in well, I've lost the question now. Let me see if I can find it. It was about bringing in a 2D DWG file from Civil 3D into Infraworks and using it as a terrain overlay. Andrew, could you speak just a bit about that?
Yeah, I have actually answered that one. So the answer to that is you can bring in AutoCAD drawings as a 2D overlay, but at this point in time, they're not coordinated. So what you need to do is bring your image, bring your AutoCAD drawing across as a 2D overlay, and you can simply, once it's in your drawing, you simply right-click on it, and you can say, I can't remember off the top of my head, it's something to do with create reference points, and you can actually do a 3-point stretch. So you grab 3 points on your AutoCAD drawing and match it to 3 points in your Infraworks model, and that will actually rescale the image and put it in the right location for you. So it is a bit of a manual process, but it can be done.
Great, thanks. And then another question for you. Can any Civil 3D corridor be brought into Infraworks, and are there any limitations on curve type or corridor components, things like that?
At the moment, we only support the centerline alignments. So rail alignments, I believe at this point aren't supported. But as long as they're a centerline alignment, then yeah, you should be able to bring any corridor that's associated with that along for the ride.
Great.
Even custom sub-assemblies.
Great, thanks. And then we have a question for Era. Can you briefly describe how we can make use of this bridge workflow for rehab projects and staged construction?
Yeah, I mean, that's a question that we see on a regular basis. If you look at this bridge, for instance, let's assume this bridge was an existing bridge that we wanted to add additional lanes to, for instance. So the first step is always to model the existing bridge. So the fact that it's not a new bridge doesn't matter. In this case, you would still use the parametric workflows. You might create some custom components if the geometry requires it, and model the existing bridge. And then maybe create a separate proposal and add the modified bridge, which has kind of the new extensions or modifications. All the bridge components, when you open up the model in Revit, can be phased in Revit. So you might say, select the certain objects and say, this is the existing bridge, and these other objects are part of phase 1 construction or phase 2 construction. So you can definitely coordinate that way. Also, I would say, if you create components such as complex abutments as assemblies in Inventor, then every part of the assembly, the wing walls, the ballast walls, the seats, can be individually selected and phased in Revit. So in the end, when you have the full BIM model as the Revit model, we just make it much, much easier in this workflow. But in Revit, you would leverage all its phasing capabilities to coordinate the construction. Or you might take it into Navis for other considerations, including 4D simulation.
Great, thanks. And then I see, let's see, there was another one that just came in. So this one is for you as well, Eric, or maybe it's for both of you. I think this has to do with the Revit importing topology. So can we import topology or topography of a certain project location from Infraworks to Revit and use it in land development detailing?
The answer
Andrew,
is yeah.
that one.
Yeah, so you can take a surface from Civil 3D into Revit via the interop tools. So you would probably first need to take the surface from Infraworks to Civil 3D, which is usually not a problem. It usually starts in Civil 3D. But once you're in Civil, you can output the data through the collaboration tab and send it directly to Revit via BIM 360.
Great, thanks. And then there was one last question that I am going to try to answer, but it was somewhere in there. It came up if there are free licenses for educational purposes, and the answer is yes. Autodesk does offer educational licensing, and I'm not sure what the exact website is, but I'm sure that you can find it on the main pages. And with that, go ahead.
Yeah, we've placed a few links in the answer panel.
Great, thanks. With that, I think we're at time, about 5 minutes over. So we'll end the Q&A here, but thank you, Era, thank you, Andrew, and most of all, thanks everyone for attending and joining us for this webinar. Have a nice day.